Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in MLV Textile and Engineering College, Bhilwara. The subject is manufacturing processes and the topic for today is plastic deformation of material. In this video lecture, I am going to discuss about the plastic deformation in the materials, different materials, and about the bulk forming process and sheet forming process. After that, I am going to discuss about the strain hardening in the material. Then I will discuss about the recrystallization temperature in the for the hot working and cold working process. Now, plastic deformation. What is plastic deformation? When the deformation is beyond the elastic limit, then this deformation is called the plastic deformation. After yielding of the material, the deformation occur in the material is called the plastic deformation. In plastic deformation, the plastic deformation is occurred due to the slip and grain fragmentation and the movement of electron in the metal and lattice distortion. These are the effects after the plastic deformation in the materials. The slip can occur and grain fragmentation also can occur. The movement of atoms can occur due to the shear force and the lattice distortion. Now the bulk forming deformation. What is bulk forming deformation? If the material are of big size, the thickness of the material is more, or we can say the cross-sectional area, the ratio of cross-sectional area to the surface area is high, then the in that type of material the forming occurred is called the bulk forming process. These processes involve the large amount of plastic deformation. In this, the plastic deformation is very big because we form the product from the bulk materials to the sheet. So there is the big plastic deformation in bulk forming processes. The cross-sectional area of the workpiece changes without volume change. Here, if the bulk forming form material is this, we have to make the sheet. Then, for making the sheet, the cross-sectional area of the material, bulk material, will change, and length will increase, so that the volume of the material keeps same. Volume should be same before and after bulk forming process. The ratio of cross-sectional area oblique volume is small in the bulk forming process. For most operation, hot warming working conditions are preferred, although some operations are carried out at the room temperature also. Mostly the hot working process preferred for the bulk forming, because here the plastic deformation is more. Therefore, we need to work on a hot working process. But some for some material at room temperature, we can also do the bulk forming. That materials are the ductile materials in nature or malleable materials in nature. Now the sheet forming process. The sheet forming process is done in the sheet materials workpiece. Sheet workpiece are the thickness of the sheet workpiece are very less. Therefore, the work on that workpiece is called the sheet forming process. In sheet metal working operation, the cross-sectional section of the workpiece does not change. The material is only subjected to the shape changes. Here, in the sheet forming process, the cross section is not changing. Before and after sheet forming, the cross sectional area is same, but here the change of shape is occurred in the workpiece. We can bend the material, we can punch the sheet material in the sheet forming process. The ratio of cross sectional area or oblique volume is high in the sheet forming process. Sheet metal working operation is performed on thin sheets which are less than 5 mm, or we can work on the strips also for making a coil of the metal by means of the set of tools called punch or die on the machine called stamping press. They are always performed on cold working operation. The sheet metal forming process are always performed on the cold working operation, because here the plastic deformation is less and the shear stress is high. Therefore, we don't need a hot working operation here. We can perform it into cold working operation. Now the strand hardening. What is a strand hardening? When the metal is formed in the cold state, there is no recrystallization of the grains. Thus, the recovery of the grain distortion or fragmentation does not take place. The strand hardening is done in the cold state. Therefore, we can say it is a cold working operation. In the strand hardening is done for increasing the strength of the material. As we can see from the mild steel stress strain diagram, in y-axis stress and x-axis strain, this is a stress strain diagram of mild steel. So a strand hardening is done after at the plastic deformation zone. So here in this diagram we can see this is a strand hardening zone for the mild steel. This is a yield point. After yield point, the plastic deformation occurred. After giving the load to the yield point, then the strand hardening occurred in the material. After that, at this point, the strength is maximum. Therefore, we can say for strand hardening process, we can increase the strength of the material. Here there is no grain recrystallization of the grain. Here there is no recovery of the grain distortion, and there is no fragmentation occur in the material. The grains here are losing their properties. Here there is the shear stress occur after the strand hardening in the grain boundaries. As the grain deformation proceeds, greater resistance to this action results in increased hardness and strength, that is strand hardening. In strand hardening, the hardness of the material is also increased due to the irregular size and shape of the grains in the materials. We can improve the property like toughness for further hot working process, but in the cold working process there is no fragmentation of the grain or recovery of the grain. Therefore, here the hardness and strength of the material increases. Now, recrystallization temperature. What is recrystallization temperature? The minimum temperature at which the completed recrystallization of the cold work metal occur within the specified period of approximately 1 hour. This is a minimum temperature of the recrystallization. the recrystallization occur after the recrystallization occur. The temperature is completed recrystallization at the cold work metal. This is the minimum temperature. After that, after this temperature, after recrystallization, the work metal will call the hot work metal. Recrystallization temperature decreases the strength and increases the ductility. As I discussed in previous slide, that if we increase the temperature above the recrystallization temperature, if we do the recrystallization of the grains, there is a recovery in the grains and fragmentation in the grains, so that after recovery the ductility of the material will increase, but we lose the strength in that materials. If we working above the recrystallization temperature, which is called the hot working process, and if we work below the recrystallization temperature, it is called the cold working process. It involves the placement of the cold work structure by a new set of the strain-free, approximately equi-axed grain to replace all the deformation crystals. Recrystallization temperature depends upon the amount of cold work of the material and has already received. The higher the cold work, lower will be the recrystallization temperature. Recrystallization temperature varies from 1/3 to half of the melting point. For pure metals, the recrystallization temperature is 30% of the melting point. And for the alloys, these are the 50% of the melting point temperature. Recrystallization temperature of the lead and tin is below room temperature. And recrystallization of the cadmium and zinc is at the room temperature. Recrystallization of the iron is 450 degrees Celsius. For steel is around 1000 degrees Celsius. Finer the initial grain size, lower will be the recrystallization temperature. If the grain size is fine, small, then the recrystallization temperature of that material will be small. Now the grain growth. What is grain growth? Grain growth follows the complete recrystallization of the material left at the elevated temperature. If we work above the recrystallization temperature, then there will be the recrystallization of the grains. So the grain growth occur after recrystallization temperature or after hot working operation. The grain growth does not need to proceeded by the recovery and recrystallization. It may occur in all polycrystalline materials. The grain growth can be occur in any type of polycrystalline materials. In contrary to the recovery and recrystallization, driving force for this process is the reduction in the grain boundary energy. In practical application, grain growth is not desirable because it lose the strength of the material. Incorporation of the impurity atoms and insoluble second phase particles are of effect in the retarding the grain growth. Here, due to the grain growth, we cannot get the precise material. In hot working operation, there is no precision of the work. Therefore, we prefer the cold working operation. Grain growth is very strongly depend on the temperature. It is depend on the temperature, as we can see that it is depend on the recrystallization temperature. If we work on above recrystallization temperature, there will be the grain growth. I am closing my lecture now. If you have any doubt regarding this lecture, you can comment on this video in YouTube. I will discuss your query in the comment. Thank you so much.